In this video, we are going to introduce vector product of vectors. It is also called cross product because we are going to use the cross symbol to define the product. In notation, we write that A vector cross B vector. The outcome of the product will be a vector which is perpendicular to both A and B vector. So now let's take a look on this picture for illustration. For example, A vector and B vector will be these two vectors on the screen in blue. Next, so we should have a vector which is both perpendicular to A and perpendicular to B vector. So this is defined as A cross B vector. But the definition, as you can see on the notes, and then the length of this A cross B vector will be equal to magnitude of A multiplied to magnitude of B and multiplied to sine theta, whereas the theta will be the angle between A vector and B vector. To emphasize this yellow vector, the cross product, which is perpendicular to A and B, so we introduce a new symbol which is called n hat to denote the unit vector which is perpendicular to A and B vector. For example, it will be like the arrow in green on the screen right now. This is called n hat. So as a result, together with the length of A cross B, so that's why by definition, A cross B vector will be equal to magnitude A, magnitude B, sine theta, and n hat. So as the definition. Next, we come to a question how to find the direction of the A cross B vector in the cross product. Because as you can see, A vector cross B vector should be talking about the vector which is perpendicular to both A and B vectors. But now we come to a question. It may be pointing up like the red one, or it may be pointing down like the right one. Both vectors, the red and the purple one, they are perpendicular to both A and B. How do we know should the vector going up or should the vector going down? So it comes to a rule we call right-hand rule to define the direction of A cross B vector. Now prepare your right hand, thumb up, and see how we can do it. First of all, we try to see A cross B vector if A vector would be like in this direction. So in this case, you will see that A cross B vector will be, or we can say A vector anti-clockwise will be moving to B vector. So by definition, and you look at your thumb, so the direction of A cross B vector would be pointing up. So on the contrary, if you ask for B cross A vector, it will be opposite to the direction of the yellow one, and this is called B cross A vector. So that's why make use of your thumb, and you see how your fingers will be turning, like anti-clockwise, following the direction of A vector to B vector. Then the position of the thumb will be telling you the direction of A cross B vector. After knowing the definition and the meaning of cross product, then we come to the operation. How can we find the cross product precisely? It won't be an easy task because it goes from AB vector on a 2D plane to a 3D space. To your surprise, in order to find cross product, we need to apply the knowledge of determinants. The way to find A cross B vector should be done in this way. First of all, you put ijk vector in the first row. Next, for example, if you find A cross B vector, so you should put the coordinates of A vector, A1, A2, A3 in the second row, followed by next B vector, B1, B2, B3 in the third row. After that, you can expand the determinant, multiplying the items and add up in this direction, multiply the items and then minus in this direction. After that, you get A cross B vector, the cross product of the question. Next, we try to take an example to illustrate how we can find the cross product precisely. For example, now I give you A vector, I plus j plus 2k vector, whereas B vector will be 2i minus 3j and minus k vector. In order to find A cross B product, at first we cannot write the vector precisely, but we try to take out the numbers one by one. First of all, in the first row, we start with ijk vector first. Next, we take out the coefficients. We have 1i, 1j, and 2k for A vector, whereas for B would be 2i minus 3j and minus 1k vector. After that, we can start doing the expansion and I start with the positive direction. For the first one, we have minus I vector. Okay, I put it in this way. The second one, we have 4j vector. And last one, we have minus 3k vector. So it is the positive direction. After that, we minus a very big thing, and in this direction this time. So first of all, we have 2k vector. Next, we have 1j and minus 1, minus j vector. And finally, we have I and minus 3 and 2. Totally will be minus 6 I vector. After simplification, and you will see the outcome will be 5i vector plus 5j vector and minus 5k vector. This is the cross product of A cross B vector. If you really want to draw a picture to illustrate the idea, it will be like A vector, B vector, so in these two directions given by the question itself. Whereas when you get A cross B vector, so this is A cross B vector, which is perpendicular to both A and B vector individually, and the outcome or the vector looking will be 5i, 5j, and minus 5k vector. So I wish you have a very brief idea of what is the meaning of cross product and how to find it. Now we come to take a look on some features of cross product. Basically, the distribution like number 3 and number 4 having A plus B cross C vector or A vector cross B plus C vector will be the expansion like we have in number system. For number 5, when we have a scalar multiplication like lambda A vector cross B vector, so lambda can be taken out. Next, we come to see one very important feature of cross product, which is A vector cross itself, A cross A vector will be 0. The reason can be found very simply by its definition. First of all, if you remember, the meaning or definition of A cross B vector should be magnitude of A vector, magnitude of B vector, multiplied to sine theta, this is the length, and finally we have n hat. And because of the theta, you will see that once theta equals 0, then you will see that A cross B vector will be equal to 0, or should be 0 vector. And now you ask for, when do you have 0 for theta? So if you remember, the meaning of theta itself should be talking about the angle between the two vectors. So the only case when you have 0 will be like the same vector, A cross A vector. In this case, regardless of magnitude A, as well as n hat, but once you have sine theta, which is 0, at the situation of theta equals 0, the A cross A vector should be 0 vector. Next, for number 2, we have to understand the formula by making use of the determinant. A cross B vector will be equal to I vector, j vector, k vector in the first row. A vector suppose is A1 I vector, A2 j vector, A3 k vector, while B vector suppose is B1, B2, and B3 in this way. So this is a way how we can really operate and find out the cross product precisely. Now you go back to the rule or feature of determinant. When you interchange the rows, if you still remember, so there should be a minus sign popping up in the determinant. So as a result, now you rewrite the determinant in this way. Second row becomes B1, B2, B3, while the first row becomes A1, A2, A3. On top, we still have I vector, j vector, and k vector. But can you see that once we write in this way, because A and B, they are swapped, so that means this one also means minus B vector cross A vector. So it helps you to prove the formula number 2. Lastly, we try to prove number 6, which is a relation between the cross product and dot product as the end of this video. So to me, I think it's not really very useful in our real application or like calculation, but let's start it. Left hand side you will see, or you have to see very carefully because it's talking about magnitude square of A cross B vector. Now please note that A cross B vector is a vector in the outcome. So that's why we can talk about the magnitude afterward. To this, we can't write A cross B vector in terms of IJK because we don't know exactly what is A vector and B vector. As a result, we can only seek for the use of the definition, which is magnitude A multiplied to magnitude B multiplied to sine theta, and lastly, we have an n hat in the definition. And now, would you please try to see that magnitude A, magnitude B, and sine theta, they are all scalar. Scalar means that it's like a constant which can be taken away from the magnitude square. So as a result, we have magnitude A square, magnitude B square, sine square theta, which is multiplied together. If you like, you can put the multiplication sign there. But do remember that because of scalars, they are scalars, so it's nothing about cross product. So it's just a symbol using the multiplication sign as we have before. Whereas at last, we still have a magnitude of n hat square in the expression. Do you remember what is n hat? N hat is the unit vector which is perpendicular to both A and B vector. If you forget about it, so let's record it in this picture. When you have A vector and B vector, then the angle between them is called theta. The mean of A cross B by using right-hand rule, which is a perpendicular vector perpendicular to both of them. So this is called A cross B vector. To indicate the importance of this direction, so that's why we define another term called n hat vector, n hat, which is talking about the unit vector in this direction. So as a result, this n hat magnitude will be equal to 1 because of the word of unit vector. So as a result, now the left-hand side becomes magnitude A square, magnitude B square, and sine square theta. When I see sine square theta, I think it's a very good expression because I know it may be something about identity of sine square theta, cosine square theta, the sum gives you a 1. By the way, it comes to the end of left-hand side because I've got nothing to do or continue about magnitude A, magnitude B, and sine square theta. Now take a look on the right-hand side. I'll put it in yellow here. Right-hand side, you have magnitude A square, magnitude B square. I think I have nothing to do on it because they are already numbers or scalar. But the main point of the other one would be because of A vector dot B vector, by the definition again, so it's A vector, B vector, or you can say multiply together, and cosine theta. So it proves my guess is correct because now it seems like a relation between sine and cosine. If you continue, so you have magnitude A square, magnitude B square, and then you do remember that magnitude A, magnitude B, and cosine theta, they are all scalar, that means constants. So as a result, you have magnitude A square, magnitude B square, and cosine square theta. By taking out common factor as well as the identity about 1 minus cosine square give you a sine square, then you will have magnitude A square, magnitude B square, and sine square theta afterward, which is equal to the left-hand side. So as a result, you can see this is the identity which is link up cross product and dot product together. But the most difficult or most important thing will be, do you understand the idea on the left-hand side? Because this symbol is talking about the magnitude of the cross product because the cross product itself is a vector. So it is the last question. I leave it to you in this video.